Hey, good morning. This is the G67 Unit 2 Assessment Review. Let's get started. The first question, label these four relationships as proportional or non-proportional. You know what? Well, let's skip and go right down to question number 2 first. We'll get that out of the way. What makes a relationship proportional? A relationship is proportional if, first of all, when graphed, the line goes through 0. 0, 0. So it goes through the origin. It's got to go through the origin. And the second thing, it has to have a all coordinate pairs, the coordinate pairs reduce to the same ratio. All right, so we got our answer. What the heck does it mean? Well, let's take a look at this first one here. This one here, it goes through 0. So this one, as long as it goes through the 0, 0 point or the origin, as long as the coordinate pair is reduced to the same ratio, we're in good shape. So 1 to 3, all right, well, that's really 1 divided by 3, which equals 0.3 repeating. 2 divided by 6, of course, is 1/3 in simplest form, which equals 0.3 repeating. And you can do it this way too. 9 divided by 3 is 3. 12 divided by 4 is 3. 15 divided by 5 is 3. 2 divided by 6 is 3. 3 divided by 1 is 3. So that's a consistent ratio of 3 to 1 or 1 to 3, depending upon how you look at it. So this guy here, this guy is proportional. This one here, it doesn't go through 0, 0. This is non-proportional. Go up and look at these top two. Dang, no graph. That's always nice when we have a graph, but we can still look and see if they're proportional or not. 0 divided by 0, well, that's 0. 6 divided by 2 is 3. 12 divided by 2 is 12 divided by 4 is 3. 18 divided by 6 is 3. So 0 divided by 3 is 0. This one's going to go through the origin here, and the ratios are all going to be the same. Let's just graph it real quick to make sure. Here's 0, 0. Here's 2, 6. Here's 4, 12. Come down through the origin. So this guy is going to be proportional. 4 divided by 0. Yeah, that's going to come through. I can already see that when I graph that. It's going to be 0, 4. It's going to be coming through up here. So this can't be proportional because it doesn't go through the origin. Let's see if the ratio is consistent. 10 divided by 2 is 5. 16 divided by 4 is 4. You can see that the ratios are not the same either. So this one here is proportional. This one is non-proportional. Again, what makes a relationship proportional? Well, when graphed, if it goes through the origin, and if the coordinate pair is reduced to the same ratio. All right, what was the average rate of change between days 6 and 30? Let me just get that up there. What is the average rate of change between days 6 and 30? I'm going to have to make this just a touch smaller. Sorry, I'm going to have to play with the tech a little here. Between days 6 and 30. Well, I like to box them off like this. 4.38 determined rate of change. We usually have some sort of a change over some sort of a unit of time. Not always, but generally some sort of unit of time. Change over time. The average rate between day 6 and 30, well, if we look at the days, on the bottom then we've got 30 minus 6. So we really have got 24 days there. And we've got 285 minus 175. 285 minus 175, that's 110. 285 minus 175, so we've got 110 days there. And if we take a look at, these are all dollars, of course, down here, because it's a balance in dollars. So it's $110 over 24 days. So if I take that 110, I divide that by the 24 days, looks like we've got $4.58. $4.58 is our, this would be the dollars of change per day. So we're looking okay there. Let's take a look at the other one here. What was the average rate of change between dates 1 and 6? 1 and 6. This was an increase, by the way, too, because it, sorry, this was a decrease. It went from 285 to 175. So this is a minus $4.58 dollars per day decrease. Sorry about that. This is going to be a decrease too. We're going from 550 to 285. So let's get that set up. So it looks like we've got on the days, we've got 6 minus 1 on the bottom, which gives us a denominator of 5 days. And we've got 550 and 285. Notice I reversed the order because I know that I know that it's going to be a negative. If you want to take 285 minus 550, you could. You'll get a negative number, but this is a decrease. We've already established that. So 550 minus 285. I got 265. I guess that's dollars in 5 days. It look more like a dollar sign. Divide that by 5. That's a $53 per day decrease. If you want to think of it as a negative $53, you can. It's going down. It's definitely a decrease. All right, let's move on. All right, we have to look and see what scale factor. I have some issues here. What scale factor was used to create this dilation? So we're into 4.7 AB scale factor. So here's the original, and here's a dilation of it. So it went from 15 to 22.50. So I'm not really sure what that is off the top of my head. So let's just try. Let's just take 22.5 and we'll box it up, and that's to 15. Like, let's see, 1 is going to be to whatever the scale factor is. You can just take, and all you're going to end up doing is multiplying and then dividing 22.5 by 15 to find out what that scale factor is. So it's 1.5. That's kind of what I thought. I knew it wasn't big enough to be 2. So the what scale factor was used? A scale factor equals 1.5 because it got larger. You could call it 3/2 if you wanted to as well. All right, of course, going from the new to this one here, if we had started with this, the original would be just the opposite of 1.5 or 3/2, which would be 2/3. All right, what's a measure of side Q? Okay, well, if we know the scale factor, we can figure that out. We got 15 is to 22.5. I could just measure it to, I could multiply it by 1.5, but I'm going to set up as a ratio. 15 is to 22.5 is 8.8 is to whatever this Q is. We'll label it here. And just pop that in. We're going to multiply diagonally there. 8.8 times 22.5, and we are going to divide that by 15. Got 13.2. 13.2. Let's just use the scale factor to double check it. Let's take 8.8 times the scale factor of 1.5 just to make sure we got the right answer. 8.8 times 1.5, 13.2. All right, we're in good shape. I'm going to go ahead and mark that over there. This is 13.2, and that's going to be meters. 13.2 meters. Got our answer? Got our answer here too. All right, let's keep moving. Using scale factor now to determine area and perimeter. Slide that down so you can see. All right, the two shapes are similar. A scale factor of 1/2 was used to create the image. That's the second one. The area of the first is 216 inches squared. The perimeter is 66. All right, they didn't even tell us what shapes they are. They is me, I wrote the question, because you really don't need to know. What's the area of the image? Okay, well, I know that for area, I'm going to use scale factor. Sorry about that. We're going to use scale factor squared. We're going to take the original area, we're going to take it times the scale factor squared. It's getting a little hard to read. I'm going to go ahead and do that. We're going to take the area times the scale factor squared. All right, so the original area of that was 216 inches squared. We're going to multiply that times the scale factor of 1/2 was used. So we really have to take that 1/2 squared, which is really 216 times 1/4, which really, when you just multiply straight across, is 216 divided by 4. And if we do that in the calculator, 216 divided by 4, we get a total of 54. So the area is going to be 54 inches squared. And that makes sense. It's 1/4 of it because you're multiplying by 1/2 squared. And we know it's going to be smaller because they use a scale factor of 1/2. It can't be bigger. All right, what is the perimeter of the image? Well, that's a little bit simpler. We just take the perimeter, the original perimeter, and we just multiply it times the scale factor. So the original perimeter was 66, and we're going to multiply that times the 1/2. That's really the same as 66 divided by 2, which is 33 inches. So we've got the perimeter of 33 inches there. All right, we're on to page 2. It's going to be a long video, friends. We'll have to break this into a couple. All right, a prism has a volume of 27 and a surface area of 54, is dilated with a scale factor of 3. What is the volume? Well, what is the volume of the new prism? So it's dilated with a scale factor of 3. So volume is going to be scale factor, whatever the original volume was, it's going to take that times the scale factor cubed. So our original volume is 27. And we're going to take that times the scale factor, which is 3, and it's cubed. That's really the same as 27 times 27, which equals, I'm going to save some time here, I cheated and did this one early, which equals 300, sorry, can't find my answers. I guess I'm not going to cheat on this one. Equals 729, I found it, 729. So the old volume was 27, and we don't have anything there, so we got to think it's units cubed, and so this one would be 729 units cubed. All right, what is the surface area of the new prism? Well, that's an area type of thing, so we can just take the original area times the scale factor squared. So the original area is 54. If we take that times the scale factor, which is 3 squared, that's really the same as 54 times 9. 54 times 9 is going to equal, clear out my thing, 54 times 9 is 486. And that's going to be units squared. We'll double check that by just taking divide that by 3 by 9 equal back to 54. All right, we got the surface area and we got the volume. Take a look at the next one. Proportions and dilations. Pentagon E prime, F prime, G prime, H prime, I prime is a dilation of EFGHI. Okay, this is a small one. These are the prime signs. Kind of hard to see, so I'll make them in there for you. What scale factor was used to create the image of that shape? Well, if we take a look at the coordinate pairs, this is a pretty good one right here. And this one here, the corresponding coordinate pair. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this pair went from 6, 6 was the original coordinate pair, and the new coordinate pair is 2, 2. So we're really dividing by 3. So the scale factor is 1/3. Because if you took 6, the original one, you multiplied it by 1/3, you'd get 6 divided by 3, which would give you that first coordinate of 2. And the other side would just be the exact same thing. So for scale factor, take a look at one set of corresponding points and see if it was multiplied or divided to create the other. See what scale factor was used. Is the dilation an enlargement or a reduction? Clearly this is a reduction. The scale factor was 1/3. So scale factor is less than 1, it's going to be a reduction. These ones here, there are going to be a couple questions on the test. We're not going to do the video on this. G67 kids have already done it or will have done it. The E67 kids will do it in the spring. These things are called the platonic solids. We're just going to use, I'm going to give you everything you need to get the 2 questions on the test right. Just give you a little flavor of it, and we'll do more work with it in the spring. What do all these platonic solids have in common? Well, first of all, these are all polyhedrons. A polyhedron is a solid shape that has polygon sides, and you notice that there's nothing flat or round or curved on here. So, and they're convex. All of these ones here, they're all convex, which means they're kind of push out. There's nothing concave. Think about the state of Minnesota. This little area here is concave. There's nothing like that on there. They're all pushing out or convex. You'll notice that they're all made with, looks like each of these are made with congruent shapes. In other words, all of these shapes here are the same. They're all identical squares, identical triangles, identical pentagons, and here's another identical triangle. And you'll also notice that at each vertex the same number of pentagons meet. So here we've got 1, 2, 3 pentagons meeting. Here on this one we've got 1, 2, 3, and then at the bottom we've got 4 triangles meeting. Up here we've got 1, 2, 3, 4, 5 triangles meeting. So at this vertex we'd have 5 triangles coming together as well. So lots of things that they share in common. What 3 regular polygons are used to create the 5 platonic solids? Well, you're either equilateral triangles, squares, or regular pentagons. So not only the sides all congruent, but they're all regular. There's not some funky, here's a pentagon, a little one that looks like a house, but that's not a regular pentagon. A regular pentagon, the term regular in geometric language means same length sides, which results in the same angles. Okay, 7.5a, with the volume of the cylinders. Well, we basically, we're going to follow this base times height as our general rule for finding volume, and we've got big B here. So basically what we need to do is find the area of this circle and then multiply it by the height. So we got to know 2 things. One thing for area of circle, which is just pi r, the old pirate one. So if we take pi, which is 3.14, and we multiply that times the radius, which is 3, times the radius again, which is 3, that's really the same as 3.4 times 9. Whoops. 3.14, I said 3.4. 3.14 times 9 is equal to 28.26. 28.26, and that's going to be inches squared. That's the area of this circle. So if you've got this, think of that as a round piece of paper and the stack is 10 inches high. You can just multiply that times 10 and you're going to get 282.6 units squared. And I'm going to double check that. 3.14 times 3 times 3 gives me 28.6. We're going to multiply that times the height times the 10, and we've got 282.6 units squared. Sorry, units cubed, it's volume, my friends. Sorry about that. All right, and this last one here, we have to figure out. We've got a diameter this time instead of a radius, and that's good for finding circumference, but we need a radius. So if the diameter is 10, our radius is going to be 5. So we need pi r. So pi 3.14 times the radius, which is 5, times the radius, which is really the same as 3.14 times 25. So I'll pop that in. 3.14 times, I'm going to clear that out, 3.14 times 25. We've got 78.5. If we just multiply that times 12, we're going to get 942. So the volume of this is 942 centimeters cubed. All right, this will be the end of the first page of the G67 Unit 2 assessment. Thanks for listening. We'll have 2 more videos just like this.